Hi, welcome back. In today's video, we're going to talk about polygons in general. This unit will be mainly about quadrilaterals, which are four-sided polygons. But to begin, let's talk about what a polygon is in general and the relationship between the angles and the number of sides that we have for any type of polygon. So a polygon is really just defined as an enclosed figure composed of straight lines. Right? The smallest sided polygon that we have is a triangle, and then after a triangle we have four-sided shapes, five-sided shapes, and so on. So we're going to talk about the relationship between the angles and the different types of polygons that exist. Let's get started. We've spoken before about how triangles, the angles inside of a triangle add up to 180 degrees. Well, in this video, we're going to talk about how do you find the total angle measure of any polygon, not just the triangle. So we know here the triangle is 180 degrees. I'm going to show you a formula, or how to derive a formula for how to figure out for any polygon. Quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, you name it. As you can see here, we have some vocabulary words. A regular polygon is really just a polygon with all congruent sides and congruent angles. So these are all examples that you see here in these images. These are all examples of regular polygons because all sides are congruent. To predict the total angle sum, right, or the total interior angle sum of any polygon, we're going to create triangles within these shapes. We know that a triangle adds up to 180. So what if we divide the image, any polygon, into different triangles? The only rule is that whenever you're constructing different triangles, the triangles cannot overlap. So here's an example. We have a square or a quadrilateral. I'm going to connect opposite points or non-consecutive points, and I'm going to form triangles. In this version, I'm only able to create two triangles. Now, the triangles could be the way that I have them here, or I can construct them with a vertical line. No matter how I draw this, whichever two opposite points I connect, or non-consecutive points, I'm only going to be able to construct two triangles, two non-overlapping triangles. Now, if one triangle adds up to 180 degrees, two triangles inside of a polygon would add up to a total of 360 degrees. So any four-sided shape, which is a quadrilateral, will add up to 360. Let's try it with the pentagon. I'm going to connect two non-consecutive points. So I'm going to connect H to K, and then I'm going to connect K to I. Notice how these three triangles are now formed, and they're non-overlapping. So if this is 180, this triangle adds up to 180, and this triangle adds up to 180. We really just have 3 times 180 degrees, which is a total of 540 degrees. So any pentagon will add up to 540 degrees. The hexagon, very similar here. I'm going to connect non-consecutive points. I can connect these, and I can connect these. Now there's several ways of connecting and constructing as many triangles as possible, but what you can see here is we have now 4 different triangles. This triangle on the left will add up to 180, 180, 180, and 180. And as I multiply 4 times 180, I get 720 degrees. So you could really calculate the total interior angle sum of any polygon if you can figure out how many triangles fit in it. So if we have this octagon next, how many triangles do you think we can construct? Feel free to pause this video and try drawing different lines here on your screen to see how many triangles you can construct. constructed 1, 2, 3, 4, 5 triangles. So if I have 5 triangles times 180 degrees each, that gives me a total of 900 degrees for my heptagon. Have you figured out the pattern? How do you figure out how many triangles will exist depending on the number of sides of that polygon? So here we have 3 sides. Here we have 4 sides. Here we have 5 sides, 6 sides, 7 sides, and we can keep going. So based on the number of sides, can you predict how many triangles we have? And then from there, we can just multiply it by 180. So notice how a 4-sided shape has 2 triangles. A 5-sided shape has 3 triangles. A 6-sided shape has 4 triangles. A 7-sided shape has 5. What are we noticing? That each time the difference is 2. 5 minus 2, 6 minus 2, and 7 minus 2. It even works here, right? What's 3 minus 2? It's just one triangle. So, if I have the number of sides, we'll call that side n, and I subtract 2, that tells me how many triangles I will create. So this will tell me how many triangles. And then each triangle is 180 degrees, so we're going to multiply this times 180. Here is our general formula that gives me the total, the interior angle sum of any polygon. For any polygon. So as long as I know the number of sides, I subtract 2, and then I multiply by 180. Do you know why it's minus 2 each time? Why do you think this actually works every single time? If you have an idea and you would like some extra credit, feel free to post it here in the comments. Tell me your explanation in the comments below as to why do you think it's always minus 2. Alright, let's move on. So, here we have our general formula, n minus 2 times 180. We can predict, based on the number of sides, the sum of the interior angles. So a triangle has 3 sides, so we're going to say the number of sides minus 2 times 180. 3 minus 2 is just 1, so 1 times 180 is 180 degrees. A quadrilateral, you would take the number of sides minus 2 times 180. So 4 minus 2 is 2. Multiply that times 180, and we get 360 degrees. This is how you can find out, right, the sum of the interior angles of any polygon. A pentagon has 5 sides. 5 minus 2 times 180. 5 minus 2 is 3. So I have 3 triangles inside that shape times 180. And we did this earlier. 3 times 180 is 540. And we can keep going, right? 6 minus 2 times 180. That gives me 4 triangles. So 4 times 180 is 720 degrees. A heptagon, 7 minus 2, gives me a total of 5 triangles. So 5 times 180 each is 900 degrees. And I can really go on forever, right? 8 minus 2 times 180. An octagon. An octagon will give me 6 triangles inside times 180. And that's 1080 degrees. And the list can go on and on, right? I can go all the way down to I don't know, like a 200-sided shape, but 200 gone, right? Any sided polygon, n-gon, we take the number of sides, minus 2, multiply it by 180, and I'll get the total. Interior angle. So why is this useful? Well, if I know the number of sides, I can predict the total degrees that they're going to add up to. So let's try some examples. To find the value of x, I first need to figure out what all of these angles need to add up to. This is a polygon that has 1, 2, 3, 4, 5 sides. I'm going to have 5 sides in this shape. This is a pentagon. So I take my general formula, n minus 2 times 180. This will give me the total, right, interior angle sum. Now, you can also just draw and figure out how many triangles you have. I have 3 different triangles, right? I can multiply 3 times 180, or I can use my formula. I have 5 total sides minus 2 times 180. So I know that this polygon has to add up to 540 degrees. Yeah? So, to create an equation, I know that the total has to add up to 540. So I take each angle. I take 7x plus 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10. All of these angles have to add up to 540 degrees. Notice how this pentagon is not a regular pentagon. All the sides and all the angles don't have to be congruent. It does not have to be a regular pentagon. Any pentagon will always add up to 540 degrees. Now, if all the angles were congruent, it would make the problem a lot easier, right? I could take the total and divide it by 5 congruent sides or 5 congruent angles. But that's not the case. So all I have to do now is some basic algebra. I combine some like terms. Since there are no values in front, there are no numbers in front of the parentheses, I don't have to worry about distributive property, right? Therefore, I can just ignore the parentheses, and I can start combining like terms. So I combine the x's, 7x, 4x, 5x, 6x, and 4x. When I add those up, 7 plus 4 is 11. 11 plus 5 is 16. Plus 6 plus 4. I get a total of 26x. And then I can combine the constants, the numbers, and I can see that the 5 plus 5 gives me 0, and then 10 plus 10 gives me 20. So after combining like terms, I get 26x plus 20 equals 540, and to solve for x, I isolate the variable. Subtract 20 on both sides. 26x equals 520. Divide both by 26. X equals 20. Now, if I wanted to figure out the measure of each angle, I can plug in the 20, and for each value, I substitute it, and I can figure out the degrees for each. Plug it in for A, plug it in for E, and I can figure out all of the angles individually. Now here we have a regular polygon, which means that all the sides and all the angles are congruent. So that simplifies things a little bit, right? Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a decagon. I have a 10-sided shape. So n equals 10. And I know that all the angles are congruent. So they're all going to be the same size. All the sides and all the angles are the same size. How can I find the value of x? Well, I know that the total for all of these angles is going to be found by using this formula, n minus 2 times 180. This gives me the total. So let's find out. A decagon has how many, what is the total degree measure of a decagon? I take 10 minus 2 times 180. 10 minus 2 is 8. 8 times 180 gives me 1,440 degrees. All of these angles combined would add up to 1,440 degrees. I only know one angle. So, how do I know the measure of just one of those angles? Well, if I have 1,440 degrees total, and I have 10 congruent sides and congruent angles, I can divide it by 10. And I can figure out that each angle will measure 144 degrees. I take the total, divided by the number of congruent angles I have. Each angle is 144 degrees. So, since this angle is represented by 10x plus 4, I can set that equal to the measure of the one angle alone. Then I can solve for x. Subtract 4 on both sides. 10x equals 140. Divide both by 10. And I'm left with x equals 14. Voila. So knowing the total is very helpful, and the fact that this is a regular polygon helps me find out that each angle is going to be found by dividing it by the total number of angles. Now let's talk about the exterior angle sum of any polygon. We've been talking about the interior, which is the inside of a polygon. We use the formula n minus 2 times 180 to find the interior. What about the exterior of a polygon? Well, the exterior of a polygon is based on when we extend, as you can see here, we have a hexagon. We take the hexagon and we're going to extend the line beyond it, creating an exterior angle. As you do that to all the sides, you're going to create an exterior angle, and you're going to keep going all around. The exterior angle is connected to the interior angle because the interior angle and the exterior will form a line, which is 180 degrees. But here we're going to be focusing on the exterior angle that's being created. I can really do this with any shape. I can do it with a triangle. If I have a triangle, I can extend the line, creating an angle here. I can extend this line, and I can extend this line, creating an exterior angle here. Now, the formula here that we're going to talk about is that the exterior angle sum of any polygon will always add up to 360 degrees. The inside will change based on how many sides you have, but the exterior will always be 360 degrees. Do you know why? Think about this. As the number of sides increases, right? Here I have 3 sides. Here I have 6 sides. The more the size increases, let's say that I have this polygon, the more sides that I have, the closer and closer this polygon is going to turn into a circle. So as the number of sides increases, the angle on the outside decreases, and it's going to have a limit. If I go to 100, it's going to get smaller and smaller and smaller. If I go to 1,000, it's going to get smaller and smaller and smaller. The higher the number of sides of a polygon, the smaller the angle is going to go until eventually it creates a circle, which is 360 degrees. So, the angles on the outside of any polygon will always add up to 360 degrees. So how do we use this? Well, let's calculate the exterior angle of one side for different types of polygons. So here we have a 12-gon, right? To find the measure of just one exterior angle, I take 360 and divide it by 12. So I know that 360 degrees divided by 12 is going to give me 30 degrees each. So the outside, right, is 30 degrees for a 12-sided shape. A hexagon, it has 6 sides, so I take 360 degrees and divide it by 6. That's going to give me 60 degrees on the outside. A 20-gon, or a 20-sided shape, we take 360 degrees and divide it by 20. And that means that each side on the outside is 18 degrees. Right? As n gets bigger, the angle on the outside should get smaller. So now notice how in this picture, I have a lot of exterior angles. This exterior angle is 7x plus 4. This angle is going to be 5x plus 4. This angle is 4x plus 9, 9x minus 6, and 4x plus 1. This is not a regular polygon, so I know that all the angles on the outside are not congruent. They're not equal. If it were a regular polygon, right, if I knew, let's say that for example this image was given and every side was marked to be congruent. If each side was marked to be congruent, then I could conclude that each angle was the same. And then I can just pick any two angles and make them equal to each other. But this is not a regular polygon. I need to figure out what is going to be the total if I add up all the angles on the outside of this polygon. And to do that, we count the number of sides. So we have 1, 2, 3, 4, 5. This is a pentagon. So the total angle on the outside of a pentagon will add up to what? Well, any polygon on the outside will always add up to 360. So there's my equation. 7x plus 4 plus 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1. Any angle on the exterior will always add up to one number, 360 degrees. On the inside, it's a different story. On the interior, all the angles will add up based on this formula. But on the exterior, 360. So let's do some basic math. Let's combine some like terms. Let's combine the x's. Let's solve for x. And then if I want, I can plug it back in and find the value of each missing angle. So 7x plus 5x plus 4 plus 9x plus 4x gives me 29x. And then if I add up all the constants, 4 plus 4 is 8, 8 plus 9 is 17, 17 minus 6 is 11, and 11 plus 1 is 12. Subtract 12 on both sides to isolate the variable. 360 minus 12 is 348. Divide both by 29. X equals 348 divided by 29. 12. So now that I know 12, I can plug it in and I can find the exterior angle for any one of these angles that I have. let's take this one last step further. Let's say that I have the measure of an interior angle. Can I find the number of sides? This is like an extension to everything that we've talking about. This sort of combines all of the rules together. I know the measure of the inside of one angle. Can I figure out the number of sides? Feel free to pause this. Feel free to try solving this on your own. And then see what we get if we can get the same thing together. The key thing here that makes this problem solvable is that we're talking about a regular polygon. So we have congruent sides and angles, right? Kind of like the image that I did in the very beginning of our set of notes. All sides and all angles are congruent. Now, depending on the angle, let's say that I have some sort of angle here. I don't know the number of sides, but I do know that the measure of the interior is 150. 150, and I can just sort of keep predicting. I don't know how many sides I'm going to have, but the inside is 150. I can use the fact that the inside is 150 to find the exterior angle. Therefore, the exterior angle will be 30 degrees each time. Can I figure out how many sides this polygon will have if the outside is 30 degrees each? Of course. I take 360 degrees, and I can divide it by the measure of each angle. If each angle measures 30 degrees, I take 360 divided by 30, and I get 12. This polygon has 12 sides. You can calculate this, right? You can find out. You can compare to see if this is true. If it has 12 sides, well, wouldn't that just make it n minus 2 times 180? Can I predict the total degree angle measure? From there, right, if I have 12 minus 2, that means that I'm going to have 10 triangles inside, which makes it 10 times 180, which 10 times 180 is 1,800, is the total angle measure. Now, if I have 12 sides in a polygon and the total is 1,800, if I divide it by 12, I can figure out how much each measures. $1,800 divided by 12, each angle will measure exactly 150 degrees, which is what we were talking about. So, if I know the interior angle, 150, I can find the exterior by subtracting it from 180, because the interior angle and the exterior angle will always form a linear pair. Once I know the exterior angle, all the angles on the outside will always add up to 360. So 360 divided by the measure of each angle on the outside tells me the number of sides. Notice how here, as an example, I have 160 degrees, which means if this is 160, the exterior angle will have to be 20 degrees. Now, this is also another polygon. I don't know the number of sides, right? This is just me sort of just looking at focusing on one angle in particular. If the outside is always going to measure 20 degrees, 20, 20, and this goes on for however many sides, I can take 360 degrees and divide it by the measure of one angle on the outside. 360 divided by 20 is 18. This is an 18-gon, or an 18-sided polygon. Same thing with 175, right? I can draw another one over here with one angle would be 175 degrees, which means the outside would be 5 degrees. If each angle on the outside measures 5 degrees, I can then take 360 degrees divided by each angle being 5 degrees, and that'll tell me the total. This has 72 sides. 72 gone. A 72-sided polygon. There it is. Given the number of sides, we spoke about how to find the interior angle sum of any polygon, right? The angles that add up to the inside of a polygon. We also spoke about the exterior of a polygon. All the angles on the outside of any polygon will always add up to 360 degrees. And then here, this merges both of them together. I hope this has helped. Please let us know if you have any questions. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate later.